This is Saxon Algebra 2, lesson 24 on page 112. The first concept, don't forget to subscribe, smash the like button, and turn on notifications. And you can leave a nice comment if you like. Actually, go ahead and do it. All right, fractional equations. Here we go. Fractional equations. They're equations that have fractions. So anytime we have fractions with an equal sign, we are eliminating the denominator. We're eliminating the denominator, always. All right? In the first example, we have mixed numbers. We've already worked some problems like this. So the first step is to write every mixed number as an improper fraction. We don't want mixed numbers. So this becomes 9/2 x, right? 4 times 2 plus 1 becomes your numerator. Minus 3/5 equals negative. 1 times 4 plus 1, negative 5/4. Then I eliminate my denominator by looking at the denominators, 2, 5, and 4. Those are my denominators. I take the largest denominator, which is 5, and I look at multiples of it. That's counting up. Multiples are counting up. And every time I count up, I ask myself, do the other two numbers go into it? All right, so 5, 10. Does 2 and 4 go into 10? 15. Does 2 and 4 go into 20?
Yeah.
So that's what I'm multiplying every term by, 20. Y'all follow that? I'm taking the largest number and counting up. So every term I'm multiplying by 20. Because that's the rule in algebra. I can't just multiply 1 or 2 terms by it, or else I change the equality. All right? So equal sign, eliminate denominator. But before I multiply, I'm going to simplify. But I can only simplify terms that are multiplied. All right, so I simplify the 2 and the 20 becomes a 10. I simplify the 20 and the 5, that becomes 4. I simplify the 4 and the 20, that becomes 5. So that every denominator is crossed off. Denominators are gone. Then I'm going to multiply. That becomes 90x minus, that's 12, equals negative 25. I'm going to add the 12 to both sides. And I'm left with 90x equals negative 13. And I'm going to divide all terms by 90. And the value of x is negative 13/90. All right, we've worked problems like this. The problems are going to get slightly more complex, but we do the same exact process. Follow the same exact process. Eliminate denominators by finding the least common multiple, simplify before we multiply, and then solve. So for example 2, we start out with 4x plus 2 over 5 minus 3/2 equals 1/3. I look at my denominators. I have 5, 2, and 3. Those are my denominators. I'm going to begin counting multiples of 5 and ask myself, do 2 and 3 also go into them? So 5, 10. 2 and 3 go into them? 15. Does 2 and 3 go into them? 20. Does 2 and 3 go into them? No. 25. 30?
Yes.
30. So I'm multiplying every term by 30. But before I multiply, I simplify. And I can only simplify terms that are multiplied. So I simplify the 5 and the 30, that becomes 6. I simplify the 2 and the 30, that becomes 15. And I simplify the 3 and the 30, and that becomes 10. Now here's what's a little different. I'm distributing the 6 to every term in the numerator. So 6 times 4x is 24x, and 6 times 2 is 12, minus 15 times 3, which is 45, equals 1 times 10, which is 10. On the left-hand side, I'm going to combine my like terms. So I end up with 24x, negative 45, and positive 12 is negative 33 equals 10. Be nice if we had no fractions for our solutions, right? We add 33 on both sides. So I'm left with 24x is 43. Then we divide by 24 on both sides. X is 43 24ths. I'm going to change up example 3 because I want you to see something. All right, does everybody understand this?
Yes.
Okay. All right, so I'm just going to change this positive to a negative. I only have 2 denominators here. But really I have 3. Because anything over 1 is itself. So I look at 2 and 7. What is the least common multiple? 14. So I'm going to multiply every term by 14. Every term. Even the 3 on the right hand side. Multiplying by 14. And before I multiply, I'm going to simplify. The first 14 becomes a 7. I simplify the second term, that becomes a 2. And that's just 3 times 14. All right, this first term is easy. 7 times 3x is 21x. This is going to be minus the numerators. So we're going to write, because it's minus that entire term. It's not just minus 8 minus 4x. It is not that. So we're going to do minus both of the terms. 2 times 8 is 16. 2 times negative 4x is negative 8x. Equals, what's 3 times 14?
42.
42. The reason I changed this to negative is for you to see this concept. It's minus the entire numerator, so that you have to distribute that negative to both of the terms in the numerator. So it becomes 21x minus 16 plus 8x equals 42. Right here, ladies and gentlemen, right here is where students are going to make a mistake. Right here. Not distributing that negative to both of the terms in the numerator. It is such a common mistake. So, when you have 2 terms in a numerator, you take this sign if it's a minus. It doesn't change anything if it's plus. But if it's a minus, then you put that numerator in parentheses and distribute that negative to both of the terms in the numerator. Got it? All right. We're going to add 16 to both sides. We'll combine our like terms. 29x is 58. Did we come up with a whole number? Divide by 29, what is x?
2.
I actually made the problem better by subtracting, didn't I? I bet they had a fraction. No, they got 2 as well. How did they get 2? Oh, it was plus 16 minus 8, which, okay, we got the same answer. All right, now, I want you to look at the overlapping triangles. All right, does everybody understand this?
Yes.
Got it? All right, I want you to look at the overlapping triangles. Overlapping triangles, when they look like this, I have 2 similar triangles. Y'all remember the symbol for similar? Squiggly, yeah, squiggly line.
Tilde. It's called a tilde.
Huh?
I think it's called a tilde.
Yeah. All right. So, what are my similar triangles? Say that again. Triangle. Okay. Okay. D, A, E. It doesn't really matter.
And triangle cab.
Yeah. C, A, B. You're right. Actually, that was great. Cab. Yes. Because really, I could see it A, D, E, right? And then I could see it as C, A, B. All right, so look at the one example. They don't have the A's, the B's, the C's, but we're gonna do the same thing. We're gonna look at corresponding sides and we're gonna make proportions. So in example 4, we have 4, 6, 9, Y, X, and 7. Okay, now instead of left triangle and right triangle, I'm gonna say the small triangle and the large triangle. And I'm gonna come with corresponding sides. All right, in the smaller one, I have 4, 7, and 9. So I'm gonna write that, 4, 7, and 9. No variables in the small triangle. In the large triangle, what side corresponds to side 4? Ten. This entire side. All right, what side corresponds to 7?
7x.
7 plus x plus 7.
X plus 7. We add that distance to that distance. And then what side corresponds to 9?
Y.
Y. So in this first row is where I have both numbers. So I'm using that in both of my proportions. I'm going to write 4 over 7 equals 10 over x plus 7. And then I'm going to go back and use 4 with 9 and 10 with y. So I'm going to use 4 with 9 and 10 with y. Do y'all see that? I'm always going to use this row. I'm going to use this row with this row. Then I'm going to use this row with that row. Got it? Now, when I distribute that 70, when I distribute this way, it's 4 times x plus 7. It's 4 times the entirety of that denominator. So that 4 has to be distributed to both of those terms. So I have 70 equals 4x plus 28. Subtracting my 28 on both sides.
42 equals
4x equals what? 42. And dividing by 4, I have x equals, it's 42 over 4, but that both of those are divisible by 2.
21 halves.
21 halves. That's the value of x. This one is easier. So this one is different and reflects the new lesson because we have the binomial. All right, so this one would be 4y, y, equals 90, and you divide by 4. So y equals 94, but both are divisible by
2.
2. I was making sure 1, 4. So half of 90 is 45. So the value of y is 45 halves.